How are we doing today? Today we're going to be solving systems of equations algebraically. That way you don't have to graph each of these. You can just, with the formulas, solve and find where the point of these graphs, where they cross. So we're going to solve it algebraically. We got two methods, maybe you remember them. First one's called substitution, the second one's called elimination. And substitution is used when you can have a y equals. Or you could use an x equals, but you get one letter equals. So what you're going to want to do is you're going to want to take one of these equations, and if y equals one value, then you can take that value, and wherever you see a y, you can replace it. So I can write this 3x minus 4, and that's going to equal 4 plus x. Now all of a sudden we don't have any y's in our equation, and so what we can do is we can solve it with one variable. So minus x to both sides, minus x to both sides, we're left with 2x's minus 4 equals 4, plus 4 to both sides, plus 4 to both sides, and 2x equals 8, so now divide by 2, x will equal 4. Now remember that these are lines. These are lines that on a graph have two coordinates. I found one x, which means the point of where they cross, the x value is going to equal a 4. But at this point, I still don't know the y value. To find the y value, I'm going to take this number, this 4, and I'm going to go and put it into one of those two equations, whichever you like, whichever works easier. Right now, I'm looking at the bottom equation. Looks simpler than the top. It will work in either one of those. But I'm going to write that equation again, and I'll write y will equal 4 plus, and now I know that x is 4, so I'm going to substitute in the 4 in that spot, and so 4 plus 4 is 8, and so our y will equal 8 when x is 4. This is the point of where those two lines cross on our coordinate grid. And so substitution takes one variable, and even though it's bigger, replaces one variable with like terms of what you already have. So you can solve for one of the variables, plug it back in, and solve for the other. And that's the point. The other option I have is called elimination. And elimination works best if both of them are in standard form. You want your x's and y's in the same spots. Now what you're going to do is you're going to treat this like an old school addition or subtraction problem. In fact, I don't like dealing with subtractions. I would much rather deal as an add. Now, I'm looking for coefficients next to either my x or my y to be the same. Not only the same, but one positive, one negative. Right now, I see a 2x and a 2x right below it. Those are the same. These are the ones we're going to eliminate. So to eliminate them, I need one of them to be negative. So what I'm going to do is I'm going to multiply this entire both sides of the equation by a -1. -1. Now I can multiply them by any value, and so if I needed to multiply it by a negative or a positive 3, and then maybe I wanted to multiply the top one by a positive 2, then my y's would drop out. But in this case, I think it's going to be easier just to multiply a -1 to each and every term. So if I multiply each of those by a -1, I'm going to get a -2x plus a -2y equals a -6. The most common mistake is you forget to multiply one of those three terms by your value. Once I do that, now I can add these two options together. So a 2x minus 2x makes 0 x's, and so 0 times anything is gone. We don't even need to put that there. -3 minus 2 more y's is going to be -5 y's. And the equals drops down. 11 minus 6 is going to equal 5. Now I can take what's left and divide by -5 on both sides of my equation, and I'm left with just y equals a -1. Once I know that y equals a -1, I know the point of where they're going to cross. The y coordinate will be -1. Now I just got to find the x. And so take that -1 and pick whichever equation you like the best, whichever one you want to solve it with, plug that back in. I'm thinking I'm going to go back to my original my original 2x plus 2y equals 6 because I like those smaller numbers. And I'm going to put this negative 1 into the y spot. So it's going to look like 2x plus 2 times, and I know y equals a negative 1, and it's going to equal 6. So now I can solve it. Negative 1 times 2 is a minus 2. Recopy 2x. So now I can plus 2 to both sides, plus 2. 2x will equal 8, and divide by 2, x equals 4. Now I know that of my point, my x-coordinate is 4 and negative 1. If you want to double check, you can grab the other equation and see if they work. Does 2 times 4, which is 8, minus 3 times a minus 1, which is a positive 3, does 8 plus 3 make 11? Sure does. This point works in both equations. This point is where those two cross. So one more problem, just to try it out. It's 10 on your homework. If they give you something like this, you have to decide, do I want to substitute? Do I want to eliminate? Which would I like to do? This one's not set up for either, so we're going to have to do a little manipulation with either of those. I'm thinking, why don't we minus 12g to both sides and write an equation of minus 12g plus 8h equals 5. And now we'll have to be able to combine it with this top equation in standard form, and we can eliminate. So now we'll look at which term do we want to eliminate. We have the two options. We have option, we can get rid of the g, multiplying this times 4, or the h. I'm thinking, let's get rid of the h. So this top equation needs to be multiplied, both sides, by we have a positive 8. We already have the negative, so we just need a positive 4 to be multiplied times both sides of my equation. So that's going to give me a 12g minus 8h equals negative 4. I'm now going to combine that with my minus 12g plus 8h equals 5. Now, this is an interesting type of problem because when I go to eliminate these, if I substitute it, I'd get the same result. Do you notice that a 12g minus 12g is 0 g's? Also, I have a negative 8h plus 8h is 0 h's. In other words, both of these are going to cancel out or make a 0, equaling negative 4 plus 5 equals a positive 1. If both of my variables drop out, they eliminate or they substitute out, you want to look at what is left. And what's left is a 0 equals 1. If they are the same, your answer will be an identity. If they are different and they are not equal, then it is going to be a no solution. Good luck. Give it a try.